Hello, friends. This is Professor Googlov. Sit back and watch today's video carefully. Here we go. Lenticular clouds. Lenticular or lens-shaped clouds are stationary clouds that could prompt news reports about alien invasions. Don't be alarmed, though. Despite their otherworldly appearance, they are perfectly normal. These formations occur at high altitudes. If you live in high mountainous regions, you might have been lucky enough to catch a glimpse of such clouds. Others can only dream of it. Lenticular clouds can be seen among the high-level standing clouds as well as stratocumulus clouds. Usually, lenticular clouds align perpendicular to the wind direction but hardly move due to their size. As a result, they twist and can resemble UFOs. But how do they form? When a stable air current passes over a mountain ridge, a series of massive standing waves of clouds can be observed right above the peaks. If the temperature on the crest of one of these waves drops and dew forms, the moisture in the air condenses, creating a lens-shaped cloud. As the moist air descends back to the lower point of the wave, the cloud transforms back into vapor. It's a fascinating and seemingly intricate process that allows us to witness one of the most extraordinary phenomena in the sky. Fall streak. Next on our list is the fall streak phenomenon, also known as a cloud hole. It's a pretty cool occurrence that looks like a large circular hole in cumulus and cumulonimbus clouds. To put it simply, it appears as if someone dropped a huge ball onto the cloud surface from above. In reality, these gaps are formed when the temperature of the clouds drops below the freezing point, but the water itself hasn't frozen yet because ice particles haven't had a chance to form. Some of the water starts to accumulate and freeze, causing a domino-like effect. The water vapor around it also freezes and falls to the ground, creating a massive hole in the sky. What sets the fall streak effect apart from its cloud counterparts? It can occur due to a combination of both natural and artificial phenomena. These holes usually form in mid-level clouds composed of liquid water droplets that become supercooled. In other words, the temperature of the water drops below the typical freezing point, but the droplets remain liquid. This can happen, for example, above the wings of an aircraft when the droplets reach the freezing point as the plane passes through a cloud layer. Ice crystals generate new crystals as the liquid continues to freeze. Eventually, the ice crystals become heavy enough to fall from the sky, leaving a void in the cloud layer. Cloud holes can appear in any location, but the phenomenon is still quite rare. These images were captured in the United States and the United Kingdom. Morning glory clouds. Have you ever just sat back, relaxed, and watched the clouds pass by? Well, the next clouds on our list don't just pass by, they actually roll. Have you often seen rolling clouds? The phenomenon is called the morning glory, and it looks like clouds have rolled into a tube and are rolling across the sky. Low, horizontal, tubular-shaped clouds are usually seen completely detached from other clouds. The phenomenon is truly awe-inspiring. The clouds resemble machines in the sky, slowly rolling by, going about their business. The morning glory is a solitary cloud that maintains its shape while moving across the sky. The phenomenon is quite rare, but, for example, there is one place in Australia that often makes headlines. The sea breezes that blow over the Cape York Peninsula and the Gulf of Carpentaria, thanks to mesoscale circulation, create the morning glory clouds. Occasionally, you can see one or two elongated tubular clouds moving over the coastal areas. The morning glory can also be encountered in California, Mexico, and even the English Channel. Morning glory clouds are incredibly powerful. As they form, they draw in so much air that it can even be detected by a seismograph. It's astonishing. Actinoform clouds. Actinoform clouds are a collection of low-level marine clouds that take on an interesting and distinct shape. The name comes from the Greek word for ray, because of their radial structure. Actinoform clouds would look great on the ceiling of a hippie's room. Actinoform clouds form in the lower levels of the atmosphere at an altitude of about 2 kilometers above sea level. They are often seen in the open waters of the Pacific Ocean, mostly in the southern hemisphere. The clouds can linger in the sky for up to 72 hours and are often accompanied by drizzle. The cloud patterns can stretch across the sky for more than 300 kilometers. Amazing. However, they are quite difficult to see with the naked eye. They are best observed from a spacecraft. Actinoform clouds can not only stretch almost 300 kilometers in length, but also form trails that can be 6 times longer than the length of the original cloud field. Despite being so scattered, each cloud has its own unique shape. Some will look like veins on a leaf, while others will look like spokes on a wheel. The most amazing thing is that no one knows exactly what causes these fractal patterns in the sky. However, recent data on actiniform clouds suggests that radiation and precipitation interactions may play a major role in their formation. Pyrocumulus clouds. If you studied Latin, you know that pyrocumulus means fire pile. Pyrocumulus clouds form from rising air that results from intense heating of the surface, such as during forest fires or volcanic eruptions. Fires that generate these clouds can be caused by both natural and artificial causes. A large fire can cause strong upward air currents that lift water vapor and ash up. Water vapor can condense in ash, forming cloud droplets. The energetic upward movement of air leads to the formation of pyrocumulus clouds, which are very similar to thunderclouds. Thunderclouds also form due to strong upward movement of air. Strangely enough, fiery clouds have a grayish or brownish color due to ash and smoke. The height of the cloud can reach up to 9 kilometers. It is difficult to accurately define the lower part of the cloud, as it is often hidden by ash, which is usually abundant during a fire or volcanic eruption. The fire and fiery cloud from above look very apocalyptic. With a large amount of water vapor, the fiery cloud can grow into a rain cloud or thunderstorm. When a thunderstorm cloud forms, it is called a pyrocumulonimbus cloud. Like ordinary thunderclouds, pyrocumulonimbus clouds can also generate lightning due to strong upward currents, and rain can also come from these clouds, which helps to extinguish the fire below. Nature is amazingly well thought out. Kelvin-Helmholtz clouds. Let's now look at something less ominous and ominous, such as Kelvin-Helmholtz instability. This phenomenon resembles the famous Japanese print, The Great Wave off Kanagawa. The picturesque clouds were named after two men who studied the physics behind this amazing phenomenon. Lord Kelvin and Hermann von Helmholtz, that's what they were called. So what did they discover? Wavy clouds occur when the upper layer of substance moves faster than the lower layer. That is, the upper layer of the cloud is warmer than the lower one, it is much less dense, so it can move faster than the colder and denser cloud below it. With a difference in temperature and density between the layers at the boundary, instability arises, which leads to the bending of the upper edge of the lower layer, causing the upper layer to roll over it like a wave. A fairly simple process creates such unique beauty. So when can you see this wonder? There are more chances on windier days when there is a difference in air density, when streams of warm air seem to envelop streams of cold air. More often, these cloud waves can be seen closer to sunrise or sunset. Clouds take on a wave shape when the air at the top moves faster than the air at the bottom. Air currents pile up on the lower layer and create a rolling wave effect. It's beautiful. But if you notice such a phenomenon at an altitude of 9 kilometers, be prepared. Kelvin-Helmholtz instability always causes turbulence. Shelf clouds. Have you heard of shelf clouds? What about a thunderstorm surge? Shelf clouds are horizontal wedge-shaped clouds. The shelf-like cloud looks like a wall that signals an approaching storm. However, a thunderstorm cloud is different from a shelf cloud. The latter will be located at the front edge of the storm, while the actual thunderstorm will usually be at the end. Now, going for a walk, you can predict the beginning of a thunderstorm. That's it for today. Thank you for spending these minutes with me. See you tomorrow.